Okay, Assalamualaikum and hello. We continue our study with the gas turbine power station. So generation station that use gas as fuel to power the turbine is known as gas turbine power generation. So this is gas. Okay. So in the gas turbine, mechanical energy is developed by combining the compression air and burning gas. So you have compressed air and you have burning gas. So initially the air is compressed in the compressor and then combined with the burning fuel in the combustion chamber. The process results in increase of temperature and pressure of the compressed air, which then with the high velocity volume to rotate the turbine and move the generator. So I think the figure is much more clear. So you can see here, you can see here air is taking into the compressor combined with the natural gas, and it will produce a high velocity gas, high velocity airflow volume to rotate the turbine generator, so it will rotate the turbine. So this is exhaust gas, and then you have a recovery boiler, and then water in, and it will heat up the steam and produce a secondary turbine, gas turbine, another gas turbine, condense it and then rotate it again. This one goes into the atmosphere. This is the water cooling tower. This is a condenser. So basically you have two compressor. So this is generator. You have two generator. One is from the compressor of hot gas and another one is from the steam. There is no waste. It just less waste produced. So the energy from the wind has become, so this one is for the wind power electrical generator. So this one is gas turbine. Next is the wind power electrical generator. So energy from the wind has become one of the potential available renewable energy resources contribute to the commercial electrical energy generation. Although currently wind generation is not significant in the most countries, however, this technology advances related to the wind generation and clean resources of the wind energy are expected to increase in the role of generation in the future. What it said is that right now wind power is not too popular, but because there are many advances in the technology in the wind power generation, this one become more popular. If you can see here, the wind turbine has become much more larger than can supply much more electrical energy. So how the wind turbine work? So wind turbine is used to convert energy from the wind to electrical energy. Wind rotate the turbine blade and electrical power is obtained when the turbine is connected to electrical generator. So you have the blade here. This is the blade. You can see at the mouse. This is the blade. So this is the main shaft, the gear transmission. So you need to have a gear here. Basically wind turbine has 4 types. So if not mistaken, this is the second type, but this one is out of your topic, no need to worry. This is brake. You need to have brake because if the wind is too high, it can damage the wind turbine. So that's why we have brake here. We have the synchronized generator. This is the high speed shaft and housing, and then this is the tower. So make sure you know the main component of the turbine. So you can see here wind turbine horizontal and vertical. You have 2 types, either horizontal or vertical. Horizontal, you can see here, this is horizontal one. It rotates something like this. But vertical one is rotate something like this. If the wind goes here, it will rotate like this. So make sure you know the types of wind turbine, either horizontal, which is this one, or vertical wind turbine. Since wind cannot predict accurately and differ from the load demand pattern, electrical supply from the wind station cannot be scheduled accordingly to fulfill the given load as other conventional generation technique. So if you recall back here, remember that I say that, for example, if you, okay, this is load. Okay, for example, if your load is 50 megawatt, okay, the generation needs to produce 50 megawatt. Okay, you needs to be balanced. P in equals to P out. But the problem is, okay, in reality, this one change. Load change according to the customer. Okay, customer change the load. Okay, but the problem is, if you use coal, for example, gas, you can control this. Okay, you can control the production of power. But if you use wind, okay, for example, the load is 50 megawatt, but sometimes if you have wind is non-predictable, so sometimes they only produce 30, okay, maybe different color, 30 megawatt. So you have P1 not equals to P out, and when this happens, your system will crash. Okay, so you cannot create energy from nothing. Okay, so you have to produce it somewhere. So when you use a wind energy, this can happen. Okay, so in the commercial generation, it is common to use to replace other generation technique at a specific time, also contribute to reserve power supply such as battery system and hydro-based pump storage. Okay, what this means is that you need to have a energy storage system. Okay, you need to have a energy reserve. So for example here, let me back this, okay, and delete this. Okay, I delete this. For example, right now the load is 50 megawatt. Okay, the load is 50 megawatt, and the wind turbine, this is wind. Okay, wind turbine only can produce 20 megawatt. Okay, this one is just example. Okay, 20 megawatt wind turbine is actually not exist yet. Okay, so try to check. Okay, try to check. If not mistaken, it still not exist. This is just an example. Okay, so wind turbine is 20, so you still need 30 megawatt. Okay, where you want to find this, you have to have a backup system, energy storage system, ESS, energy storage system. So this one 20 megawatt. Okay, this one is 30 megawatt, and it produce 50 megawatt. That is mean by this sentence. Basically, you have to have a reserve supply to cover up the energy need. Okay, this is what happen if you have energy demand. Okay, you don't have enough energy. But if you have extra energy, for example, this one becomes 60. Okay, 60. Okay, let me change this. Okay, for example, if you have surplus, okay, 60 megawatt, okay, you have 50 and then 50. Okay, so this one is 60, 50. So this one become, it go like this, so negative 10 megawatt. So basically it goes into the energy storage system. So that's why in the wind turbine you have to make the wind turbine larger, so you can charge the battery and can be used later on. Okay, so how to calculate wind turbine? Okay, so wind turbine here, blade of wind turbine rotor normally cover a circular area. This area can be calculated with this. Okay, area is pi r squared. Okay, so you can see here, this is the area. You can see the mouse here. This is the area coverage. So you calculate the area coverage by the rotor. Okay, and then you can calculate the power. So power obtained from the wind depend on the area covered by the rotors and the speed and density of the wind. So P is power, okay, equals to half. D is the wind density of the air, A is the area, and V is the velocity of the wind, okay, V cube. Okay, this is how you calculate the power produced by the wind. Okay, so one thing you need to know that air density depends on the elevation or height above the ground, while surrounding temperature does not significantly affect the energy produced by the wind. Therefore, the magnitude of the wind power is 0.625 AV cube. Okay, so basically half of density is 0.625. Okay, so this is just a constant. Okay, so wind power density is the parameter normally used and defined as power from the wind per unit area occupied by the turbine wind blade, wind per meter squared. Okay, so power density is equals to 0.625 V squared 3. Okay, this is the power density and this is power. Okay, so you need to know the equation. Okay, just a simple equation. Okay, this one magnitude of the wind. Okay, P is equals to 0.625 AV cube. Just memorize this. And what is power density? Okay, wind power density is this one. Okay, next we move on to another part, which is direct conversion method, solar energy. Okay, solar energy is basically one of the preferred method used for energy. Okay, because right now solar is quite cheap. Okay, this is due to the fact that energy is renewable, clean, and doesn't have significant impact into the environment. Okay, by sun ray, okay, the ray from the sun or the irradiance is estimated to produce 1000 watt per meter squared energy at the sea level on the earth surface. Okay, so this is just a constant. Okay, not a constant but estimation. Okay, however, the energy conversion process to electrical energy is the available technology at this moment is quite low. Okay, so basically the efficiency of the solar, okay, PV model or solar is around 10 to 30% only at the current technology. Okay, so if you look at this, it's only around 10%. Okay, for this one is 10%. Okay, you cannot just convert everything into energy. If you can see the technique before, many of the technology right now is still not efficient. So you can see here solar energy is still in the early stage. Okay, I give you an example here, and a photovoltaic panel with an efficiency of 15%, which is a standard right now, is normally able to generate between 19 to 60 watt per meter squared, or 0.45 to 1.35 kilowatt hour per meter squared per day. So you can see here it is very low energy. So this is just for a meter squared. Therefore, you need a lot of area to produce a usable energy or commercial energy. Okay, so 19 to 60 watt per meter squared, and this one. Okay, so this is the arrangement of PV panel that used to generate electrical power. So you can see here, this is the panel. Okay, this is one panel, or we usually call it PV module. Okay, and when you combine this all together, it's called PV array. Okay, this one is PV module or PV panel. All of this is called PV array. Okay, Okay, typically energy from the sun ray is converted into electrical energy by utilizing the PV cell, okay, or known as the photoelectric cell. Okay, PV cell is a semiconductor that receives photon from the sun and to produce a charge carrier, electron and hole in the cell. Okay, the separation of charge carried by the converter side result into the current flow. Okay, this is called a photovoltaic effect. So you need to know what is photovoltaic effect. Usually will be asked in the question test or final exam. Okay, so make sure you know how to explain photovoltaic effect. Okay, basically your sun ray. Okay, the PV cell is a semiconductor. This is one point, and then receive photon from the sun ray. Okay, another point, produce charge carrier. Okay, electron and hole in the cell, and separation of charge result in electrical current. So you need to know this. If not mistaken, is 4 point. Okay, so this is what I explained before. Photovoltaic effect in PV cell. You have the sun ray, okay, goes into the cell. Okay, so okay, what is cell? Maybe you don't know it. Okay, let me draw this. Okay, the smallest unit of PV is cell. Okay, this is cell, a small cell. Okay, you combine this together. Okay, combine the cell. Okay, in series. Okay, become string. Okay, and then you put this maybe inside here, inside this. Okay, inside here. Okay, you put it in series, these cells. Okay, this is the cell, PV cell. Okay, and then this one become a panel or module. Panel or module. Okay, so basically combination of cell will become panel or module, and combination of module. Okay, you have module, multiple module. Okay, it will become array. Okay, so you have to combine together. Okay, to produce a voltage. Okay, to produce a significant power or energy. Okay, so you have the sun. Okay, this one, as a result you produce a DC current. Okay, so make sure you know for synchronous generator the output is AC, but for PV this one is DC current flow. Okay, not AC, is DC. Okay, so a PV system for generation alternating current source is normally consists of the following component. So because we using a AC system and PV module, okay, produce DC output, so you need to convert from DC to from DC to AC. So this is PV panel, this is the symbol. Okay, triangle. Okay, something like this. So DC, and then you need to convert to AC, you need to have an inverter. Okay, and it will produce AC. Okay, this one is DC. Okay, so this is important aspect of PV. Okay, so you need to have PV cell module. Okay, the module or the panel, a junction box or charge regulator. This one is to control the charging process at the battery. Okay, and then you have fuse, DC wiring. Of course you need to have DC wiring, you cannot use AC wiring. Okay, DC and AC wiring is different. Also the fuse is also different. This one is out of topic, so you don't need to worry, but you need to know that the fuse and wiring system is for DC. Okay, and then you need to have a battery, and of course you need to have inverter. So inverter, if you don't know what is inverter, is basically INV inverter, basically just convert DC to AC. That is the function of inverter. Okay, so let me draw it for you, easier for you to understand maybe. Okay, so you have a PV panel here. Okay, it goes into charge controller. Okay, charge controller, and then it goes to battery. Okay, and you goes to inverter I and V. So this one is still DC, battery is DC. Okay, the output is DC. Okay, and after the inverter is AC. Okay, so it goes to load. Okay, or okay, it's something like this. So this is PV. Okay, PV module or PV array. Okay, so that is how to configure this. Okay, so junction box and everything is all in this. Okay, you actually usually we connect it to junction box and again go here, and this one to here, this one to here. Okay, we don't connect it directly for safety. Okay, so no need to worry, this is out of the topic, but you need to know the component involved in the solar, especially inverter, charge controller, okay, and battery. Okay, so it is available actually. So you can see here, this is a junction box, goes into the charge regulator or charge controller. Okay, goes into the battery and then goes into AC, inverter or fuse wire system. Okay, it's actually a lot of configuration, but for your subject I suggest you just follow this one. Okay, you just memorize the system and just apply this one. Okay, so mine is different system maybe. Okay, so use this one. So you have PV module, junction box, charge regulator, charge the battery, and then also the battery is connected to inverter, and this one is for 12 or 24 DC load. Okay, another thing you need to know, battery. Okay, battery unit is used to store the energy produced by the PV cell during the day, which then consume at night. Okay, as you know, the PV only, the solar energy only at during the day, so at night you don't have the energy, so you need to have a battery unit similar to wind. Okay, so for this case you need to have a battery for the consumption at night. For wind, the battery is used when the wind is not available. Okay, for commercial scale application, normally the PV system is connected to grid system. Okay, so this is for commercial. Okay, you have grid system, you don't have battery. Okay, so battery usually for standalone system, but for commercial scale usually we use a grid tie system, means connected to the grid. Okay, okay, another thing is inverter. Okay, there is also inverter component or power condition unit. So this one, okay, this one and this one. Okay, the function of power PCU. Okay, oh sorry, this is PCU, power conditioner unit. PCU is inverter. Okay, inverter or a power conditioner unit is the same thing. Okay, the function of PCU is to convert DC to AC power that fulfills the voltage and power quality specified by the power grid system. Okay, this unit also cut the supply to the grid if the grid is not functioning. Okay, this one, okay, usually for the grid tie system. Okay, maybe I should draw this. Okay, so system, PV system, you have standalone or you have grid tie. For standalone you need to have battery. Okay, battery. For this one you don't need battery, but you need, and this is TIE, you need to connect to grid. Okay, so you need to connect the system, PV system, to the grid. Okay, and also when the grid is down, if the grid is down, usually it will disconnect from the grid. It's just for safety reason. Okay, because if grid goes down and the technician wants to repair it, if the PV is still connected, they can get shocked. So that's why it for the grid connected system, it is disconnected. Okay, so this is the connection arrangement: PV array, inverter, okay, power conditioning unit, and then the distribution panel, and then AC load, electrical utility. So this one is the grid. Okay, you can use on your own AC load, and you can go it to the utility grid. Okay, so that's it from solar. Okay, if you are interested in solar, you can read about net energy metering, or NEM. This one is for Malaysian only. Okay, if you are interested to install PV panel at your home, you can read about it at SEDA Malaysia. Okay, it's called net energy metering NEM, or right now is NEM 3.0. You can reduce your electrical bill by using solar energy. So this is just an additional information. You can read about it. Okay, that's it. You have completed the chapter 3 part generation. Okay, after this we will continue with the transmission. Okay, that's it. Thank you. See you again next week, and don't forget to slide in your attendance, and make sure you to submit the assignment 1, if not mistaken, next week. And also try to prepare for your test 1, if not mistaken, is 10 January 2022. Okay, see you again next week.